Dear students, welcome to my second class on module 2 Fourier series. So in the previous class we learned about how to identify the odd function and even function and two problems on the odd and even functions also. So in this lecture video we will be discussing few more problems on the same concept, that is on odd and even functions. Problem number 3, expand mod of cos x in a Fourier series over the interval minus pi to plus pi. So always the first thing is we'll be taking the formula. So consider f of x is equal to a naught divided by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity b n sin nx. Call it as equation number 1. Okay, now our job is to verify the function is odd or even function. So as I told, so replace x is equal to minus x to check the function is odd or even. So given function is f of x is equal to mod of cos x. So now I'll be replacing x is equal to minus x in the above expression here. So I'll be getting f of minus x is equal to mod of minus cos x. So this will become plus cos x only. So it is again f of x. So hence we got the function f of x is an even function. So since the function f of x is even, so no need to find the value of bn, because the function is even means always the value of bn will be 0 in the interval minus pi comma plus pi. Now our job is to find the Fourier coefficients only a naught as well as an with the following formulas. So first we will find a naught. So a naught is equal to 2 divided by pi integral 0 to pi f of x dx. The constant 2 by pi I'll keep as it is, integral 0 to pi. In the place of f of x I am going to replace the function mod of cos x into dx. So as we know that the mod function will be having both positive function and negative function also. So same thing here also, I am going to expand this mod cos x like this. One is cos x, one is minus cos x with the following limit. So we'll be getting 2 by pi integral 0 to pi by 2 cos x dx plus the integral pi by 2 to pi minus cos x dx. Okay, now I'll be doing integration. Cos x will become sin x after integration. So we got 2 by pi sin x with the limit 0 to pi by 2 minus sin x with the limit pi by 2 to pi. So now here applying the limit, applying upper limit, replacing all x terms by pi by 2 minus lower limit is 0. So here upper limit is pi, lower limit is pi by 2. So we got 2 by pi into sin pi by 2 minus sin 0 minus sin pi minus sin pi by 2. So as you know that sin 0 will be 0, sin pi also 0. So sin pi by 2 is 1. So we got 2 by pi is 1 minus 0 into 1 minus 0 minus 1. So we got 1 minus 0 minus 0 plus 1, it will become 2. So the value of a naught will be equal to 4 divided by pi. Okay, now we will find an. So the formula for an is 2 by pi integral 0 to pi f of x cos nx dx. So in the place of f of x, I am going to replace the mod cos x function. So same like a previous step here also, I will be expanding mod cos x as two functions. One is plus cos x, one more is minus cos x. So we got 2 by pi integral 0 to pi by 2 cos x into cos nx dx integral pi by 2 to pi minus cos x into cos nx dx. So now after simplification I'll be using here, so 2 by pi integral 0 to pi by 2 1 by 2 into cos of n plus 1 x plus cos of n minus 1 x we got. So again I'm applying cos a cos b formula for this equation, and same thing for next equation also, integral pi by 2 to pi 1 by 2 into cos of n plus 1 x into cos of n minus 1 x into dx. So now after integration, so we got 2 by pi, the constant 1 by 2 I'm taking outside, cos will become sin in the entire equation. So I got sin of n plus 1 x by n plus 1 plus sin of n minus 1 x by n minus 1 with the limit 0 to pi by 2. Same thing here also, sin of n plus 1 x by n plus 1 plus sin of small n minus 1 by n minus 1 with the limit pi by 2 to pi. So now applying the limit, so applying upper limit and lower limit for the first function. So we got 1 by pi sin of n plus 1 pi by 2 by n plus 1 plus sin of n minus 1 pi by 2 by n minus 1. For lower limit 0, sin will become 0. So directly I am writing 0 0 here minus next function. So applying upper limit for function. So I'll be getting sin n plus 1 pi by n plus 1 plus sine n minus 1 pi by n minus 1, and you know that sine n pi will be always 0, so this term will become 0. Now lower limit, applying x is equal to pi by 2. So we got minus of sine n plus 1 pi by 2 by n plus 1 minus of sine n minus 1 pi by 2 by n minus 1. So now after simplification, we got the equation like 2 times of sine n plus 1 pi by 2 by n plus 1 plus 2 times of sine n minus 1 pi by 2 by n minus 1. So this will become 2 by pi into cos n pi by 2 by n plus 1 minus cos n pi by 2 by n minus 1 we will get after simplification. So therefore now taking cos n pi by 2 common factor, we go 2 times of cos n pi 2 by pi into 1 by n plus 1 minus 1 by n minus 1 is equal to 2 by pi into cos n pi by 2. So taking LCM here, we'll be getting the equation like this. So now after simplification, we got the value like an is equal to minus 4 by pi cos n pi by 2 by pi into n square minus 1 if n is even only, not odd. For example, if n is equal to 1, in this case the answer will become infinity. So now we have to find the value of an at n is equal to 1. So we'll find that. So now to find the value of a1, so in the equation an, I'll be replacing n is equal to 1. So we got a1 is equal to 2 by pi integral 0 to pi by 2 cos x cos nx dx minus integral pi by 2 to pi cos x cos nx dx. So here I'm going to put n is equal to 1. So after replacing n is equal to 1, we got a1 is equal to 2 by pi integral 0 to pi by 2 cos x dx minus of integral 0 to pi by 2 to pi cos x dx. So after simplification of this equation, we got 2 by pi integral 0 to pi by 2 cos square x dx minus integral pi by 2 to pi cos square x dx. So after integration, so before that I'll be replacing cos square as 1 plus cos 2x by 2. So we got 2 by pi integral 0 to pi by 2 1 plus cos 2x by 2 into dx minus integral pi by 2 to pi 1 plus cos 2x by 2 into dx. That 1 by 2 I will take outside. We got 2 by pi into 1 by 2 integral 0 to pi by 2 1 plus cos 2x into dx minus integral pi by 2 to pi 1 plus cos 2x into dx. So now after integration, we got the equation like 1 by pi x plus sin 2x by 2 with the limit 0 to pi by 2 minus x plus sin 2x by 2 with the limit pi by 2 to pi. So now applying the upper limit here, I'll be getting 1 by pi by 2 plus 1 by 2 into sin 2 pi by 2 and lower limit will be 0. And here applying upper limit pi plus sin 2 pi by 2 minus lower limit is pi by 2 minus 1 by 2 sin 2 pi by 2. So after simplifying this, so I'll be getting 1 by pi by 2 plus 0 minus pi plus 0 plus pi by 2 plus 0. So the value of a1 will be equal to 0. So now we'll be replacing all this a0, a1 as well as an for n is equal to 2, 4, 6 in the above expression. So we got the expression like f of x is equal to 1 by 2 4 by pi plus a1 cos x plus summation n from 2, 4, 6 till infinity an cos nx plus 0. So after simplifying this, we got mod of cos x is equal to 2 by pi plus 0 plus summation n from 2, 4, 6 till infinity minus 4 times of cos n pi by 2 by pi n square minus 1 into cos nx, or mod of cos x will be equal to 2 by pi minus 4 by pi summation n from 2, 4, 6 infinity into cos n pi by 2 by n square minus 1 into cos nx is the required solution. Thank you.